so how do we teach math more classically? Um, I think a useful way to break it down is to try and understand the grammar, logic, and rhetoric of mathematics. And by those, well, the classical school movement overloads grammar, logic, and rhetoric in a lot of different ways. We equivocate those pretty frequently. So when I talk about grammar, what I mean are the basic rules for manipulating the language, for manipulating the symbols. Let me offer you an example. When you teach kids arithmetic, when you teach them to add, what you're doing is you're teaching the kids the rules for how to manipulate mathematical expressions that have a plus sign in them, right? So when you teach them to add, you're teaching them to remove plus signs, right? If you have 7 plus 3, that's the same as 10, right? We can rewrite that so that it doesn't have the plus sign in it anymore. In passing, I think it would be a good idea to teach the kids that you can do that in reverse, right? That if you have 10, you're totally allowed to write it as 7 plus 3, or 6 plus 4, or 8 plus 2, or 110 minus 100, right? That those operations are symmetrical and that you can go both ways. I'd love to see a math quiz where the kids were given the number 7 and asked to rewrite it in 10 different ways, 4 of which contained exactly 1 plus symbol, 4 of which contained 2 plus symbols, and 2 of which contained 6 plus symbols, right? You could certainly do that, and if the kids can do that, then it shows that they understand the rules that govern the plus sign, that they can manipulate it freely, that much like a chess player can make the pawns bend to his will and they'll do what he wants in service of his chess game, these students can bend plus signs to their will and use them. That makes math students seem more evil than I perhaps intend. There are a lot of those. The rules of grammar in mathematics aren't something that just get taught in elementary school. When students move on to trigonometry and they learn about sine and cosine and tangent, right? Those are new symbols and the students need to learn the rules of how to evaluate them. So when the students see the sine of pi over 2, they need to know that that's equal to 1. During calculus 2, when the students see the integral sign for the first time, they need to understand what are the rules that govern how this bizarre new funky-shaped S works. So that pursuit of grammar really extends throughout the entire curriculum. You're always teaching kids the basic rules of how to manipulate symbols in math, of how to manipulate expressions. Let's talk about logic for a little bit. When I talk about logic, I'm talking about the skill of analysis, right? Analysis is the skill of taking things that are complex and breaking them down. It's the skill of evaluating statements in context with other statements. So when we teach formal logic, right, we're teaching the analysis of the English language. If I say all men are mortal, and that Socrates is a man, then I know that Socrates is mortal, right? I've taken 2 statements in English about men, mortality, and Socrates, and I've shown the truth of a third. Well, we do the same thing in mathematics. If I know that y is equal to 2x plus 1, and I know that x is equal to 2, well, then I also have to know that y is equal to 5. And there are rules in mathematics that govern how we deal with statements, how we derive new true statements, how we evaluate statements to see if they're consistent. So I think that we need to explicitly teach students how to do that. Right now, I think we do an okay job of the grammar. I think we could do a better job. I think that when we teach the grammar of math, we need to teach it to a standard of complete mastery. Much as when you learn to play chess, if you're fuzzy on how the bishop works, you'll never really enjoy playing chess for 2 reasons. One of them is your opponent will always be telling you, you can't do that with your bishop. And the other is you're going to lose, right? If you don't have a clear model of how the bishop works, you're going to have a terrible time thinking through the strategy of what's going on the chessboard. Similarly, if you don't really know what's going on with that bizarre little cross-shaped symbol that looks like 2 lines intersecting each other that keeps popping up between your numbers, well, you're never really going to enjoy mathematics. Because instead of thinking about the larger problem, instead of thinking about what you want to do with the math, instead of thinking at that higher level of abstraction, you're going to be thinking to yourself, oh dear, what do I do with the plus sign again? How does that addition work, right? You'll never be able to see the forest for the trees. So I think we need to teach that grammar to a very high level of mastery. With my students, this traumatized them until they figured out how it worked, at which point they really liked it. For the grammar of mathematics, I gave them all or nothing quizzes. the first mistake they made counted 100 points off, and I would let the rest of them slide. Now, that sort of brutality would cause them all to immediately fail. So what I did was I allowed the students to retake the quiz as many times as they wanted until they passed it. I got a lot of practice at making math quizzes. I wrote oodles and oodles of these things. But at the end, the students would have mastery of whatever grammatical concept they needed, and then they could go on and build on it. So I think it's important to really lay that foundation well. Similarly, when you're teaching the kids logic, it's important that they be able to manipulate those statements. I don't teach it to quite the same neurotic level of detail that I teach the grammar, but it's important. Excuse me. It's important to have that down. Finally, in math, there's rhetoric. When I talk about rhetoric, I'm talking about synthesis. I'm talking about context. That is, how do we take the mathematics that we're learning and move it into a larger intellectual world? And there are two phases to that. One of them is understanding what math problem. I don't like the term math problem, but I don't have a better one. When someone asks you a question, realizing that the answer is going to involve mathematics, figuring out what mathematics the answer is going to involve, and then figuring out how to move through a series of mathematical statements and expressions to get at what you're interested in. That's rhetoric. Much in the same way that you would write a paper in an English class, right? You can write papers in a math class. You can give the kids a broad synthetic question and give them time, give them space, give them reassurance, and give them absolutely no assistance or help with the mathematics, and allow them to work through that problem space until they come to an answer. Is it scary? Sure, the first time. But like all things with practice, it becomes familiar, it becomes something the students are accustomed to, and it becomes something the students really enjoy. Because in doing that sort of synthetic work, they can see that the math they've learned, that the grammar and the logic that they've learned, right, are vehicles to beautiful expression, are vehicles to allow them to communicate in this really very elegant language, to say things concisely that would be very hard to say otherwise, to think through problems, to think through questions. They can see that all the grammar and logic that they've learned allows them to think through larger problems. It allows them to think through real-life applications. It allows them to think through these whole little worlds that they can play in. And that's something that's valuable to students. Much like when we learn English, we learn it so that we can read beautiful literature and so that we can write, so that we can participate in that in the great human conversation. We learn math so that we can read good mathematics and so that we can participate in the great human mathematical conversation that stretches back to the dawn of history.